Hello, my name is Chris Berlante. I'm a principal sales consultant at Oracle in the North America Channels Group. Today, I'm going to talk to you about the advantages of running Oracle 12c on Oracle systems and Oracle storage. Today, the advantages of running Oracle 12c on Oracle hardware. I want to tell you a little bit more about a project we've been working on for the last 5 years, which is moving this smart database platform all the way to the CPUs. We recently announced the new SPARC M7 CPU at Oracle OpenWorld this past October. This has taken our hardware and software engineers 5 years to develop this CPU. It's been quite a journey because it's hard. And we're not afraid of hard things. If you look at our server processor history, roughly speaking, 20 years ago was the beginning of 64-bit computing. And 10 years ago, roughly, cores and threads and virtualization burst into the scene. Well, what we did, and this is a unique benefit that Oracle has as a combined software and hardware company, is we took a set of ideas, we built a microarchitecture simulations, when we then chose the most promising ideas and we coded them in the language that you build processors on. And we can run full simulations on top of these. Okay, so now there's 3 classes of algorithms that we worked on with the hardware team to embed in the M7 CPU. One is database acceleration. So we put this database accelerators directly in the chip. So we can run database algorithms and specialized processors directly in the chip, much faster than we can do with conventional CPU cores. Another part is getting more capacity into the same chip. And the third part is getting much more secure environment for the in-memory database. So we've been actually shipping this in our 12c database product since earlier this year. And as soon as you deploy this chip, it basically comes alive. So it's not something you have to wait for. We have all these algorithms embedded in the currently shipping database, and it's there, just ready to go. So first of all, database accelerators. So we have this new database in-memory algorithms. They're extremely fast algorithms. And on conventional chips, we've integrated with something called vector processing. So normal chips have these things called vector units, which we put there for graphics acceleration. And we've taken advantage of those in our in-memory database. Very, very fast. On the SPARC M7 chip, we said, okay, it's great that we have these vector processors in there, but those aren't really what we wanted. Those are really put there for graphics. Let's put in what we want. And what we want is not some instructions of some kind that runs stuff in the vectors. What we really want to do is hand off the work to the processors. So we want specialized coprocessors. We want 32 of these specialized coprocessors on the chip that we can hand the database work to. So for example, in a very simple example, I'm searching for orders that were ordered in California. And I want to hand that data, and I want to tell the processor, hey, my order's over there. Search all that, find the ones that apply to California, and return me the results when you're done. So that kind of work that we've done with the database accelerators that are directly into the processors is amazing. It's basically small coprocessors that optimize to run simple database functions, but they run extremely fast, and that we can hand this work off to. In the meantime, we go off and process other parts of the query, and then when it returns, we put the whole thing together. So we're basically freeing up the basic CPU. So that's the kind of algorithms we built directly on the chip. And the beauty of these algorithms is they are very specialized to run just database functions. And they take up very little chip real estate. So we've added 32 equivalent database processors on these chips, and we've only used 1% of the chip real estate. So because they're highly specialized, highly optimized, you can do it with almost no overhead on the entire chip. it's almost no cost. It's basically free on the chip to do this dramatic acceleration. And this works perfectly with 12C. It was designed to work with Oracle 12C. So, secure silicon memory really started this concept of how do I protect in-memory arrays? And then the database team worked on this. They quickly realized that this particular idea was way bigger than a database that we could use to secure kernel modules against a compromised attack. We could use it to help people develop software. We could use it in production for applications that nobody knows, understands, or can fix again. So we generalized it. The goal here is to protect data in memory. Again, the idea is simple. We have a set of keys that relate to memory access. Now, for those of you who say you're thinking about this, gosh, I'll write a program and try different keys, you don't get access to those. They're so hidden in the hardware, and no application, nor does the operating system have availability to change those keys, except when the hardware is allocating memory. So this is a very protective system for memory access. It will protect you against latent problems that you don't know about, because in fact, the attacker or the program bugs that haven't hit all the testing you've done in the millions of hours. This is a big, huge win for protecting in-memory database, especially for the new 12C product. So here's an example of a very large online retailer that was a beta tester of our M7 product. And what they found when they turned on and off the database accelerators, which is the data analytics query accelerators, they did a set of queries around their product category, and they got 83 times improvement in the responsive of the query. That's comparing to software in silicon in memory to running their database on an all-flash storage. So 83 times. Now, I don't believe all you're going to see this, but even this customer, some had queries that were faster. What happens is when the data gets bigger, the advantages get larger. On smaller data sets, you won't see as much of improvement because the efficiency in the coprocessor isn't scanning as much memory. But on the larger 12C data sets, you're going to get a tremendous performance boost on very simple queries. Now, this also translates into how do we just have a million servers in our data center. So we have a team that took a real set of customer workloads that are a combination of analytics and OLTP. So they have some things that are OLTP and some things that are analytics. And they take and reproduce the same query rate with the T7 processor. And what they found was in this particular application, and this is it's not a regular benchmark, but the team was asked to make it real. It's a terabyte database, and we think that's pretty realistic. As databases get bigger, the advantages grow. So a terabyte database, like I said, is pretty realistic. We're able to achieve exactly the same combination of OLTP transaction rate of 180 cores of an HP on 32 cores of a T7 server. So 180 cores versus 32. Since the analytics are largely offloaded by the coprocessor in terms of scans, we can safely combine both workloads onto the same box. And since we're able to have more compressed memory, we can put the entire database into 120 gigabytes, even though it's a terabyte. So we think this is a perfect example of engineering SQL in silicon. Again, this is something we've worked on for a long time with the 12C database. So our philosophy is a balanced design. We just don't add a bunch of cores and not change the memory bandwidth. We lowered the memory latency. We lowered the cache latency. We doubled the memory bandwidth. We tripled the I/O bandwidth to improve coherency function. Everything about the chip is improved. And so that makes a combination we think is a massive breakthrough in system and processor design. Starting with taking a step in security, the secured silicon memory and the encryption acceleration having built all the software in Solaris, and then the databases and so on take advantage of those by incorporating SQL and Silicon. And we have offload engine for a common operation. So the data analytics accelerator has the ability to use memory more effectively. And then, and that combination is just classic, very high performance processor. So we can give you the fastest processor, and you may not care about that, but I believe you will care about your security in memory, especially if you use the 12C in-memory option. So just here's a picture of software in Silicon. It's very interesting. People think, about Oracle as a software company. What has happened as a software company? We have the ability to understand what problems to go solve. And we picked up the pace of Silicon development. This is now our 6th processor in 5 years, more to come. But this is historic because this is where we break the code with putting software functions into the silicon in the processor. In addition to big leaps in performance, there's going to be more to come. And another thing we've done here is we really matured our ability to develop and deliver all the software at the same time. So we announced a complete new family of servers. These are the world's fastest processors and the world's most secure with memory protection and incredible encryption, acceleration, software built into Silicon and data analytics and accelerators. We have tremendous scalability all the way up to 4,000 threaded systems. So whether you sample by the drink or through the cloud, or you need to run the largest on-premise infrastructure in the world, we have a plan that can give you exceptional performance, security, and efficiency. I'd like to spend a few minutes talking about the Oracle storage strategy as it relates to the 12C database. Oracle delivers the fastest and most efficient storage systems for a heterogeneous data center environment. Oracle advancements that make the Oracle software run the fastest and most efficiently. To address all these challenges, Oracle has a different and better approach than any of our storage competitors in the marketplace. Only Oracle is co-engineering hardware and software together from the application to the archive, breaking down traditional barriers between the database and storage in order to have databases that are storage aware and storage that is database aware. We see the world through the eyes of the database administrator. The database and the application, we look at that directly. Where can we solve the problem? We therefore aim to make solutions that create less cycles for your compute resources, that enable you to store less data and optimize your data storage infrastructure, that simplify your overall IT environment. This is distinctly different from a competitor who sees the world through 4 walls of a physical box. Others can integrate, some can optimize, only Oracle can co-engineer. Here is our ZFS storage family. This is our flagship NAS product. It has high performance and low latency, and it's designed to work with our Oracle software products. This is the 5th generation of our NAS product line. The ZS series of storage empowers database administrators and your IT staff with Enterprise Manager integration. Using the tools they use already for their database management and monitoring, they can do self-service monitoring and provisioning of the ZS series through Enterprise Manager directly. This includes setting alerts and doing reporting, all through a single pane of glass, a common interface. I'm going to talk to you about the following 3 software features that are designed to work with the Oracle 12C database. Oracle Intelligent Storage Protocol, OISP, hybrid columnar compression, HCC, Advanced Database Optimization, ADO. So Oracle Intelligent Storage Protocol is a great example of co-engineering unattainable by other storage vendors because it opens a direct line of communication between the database and the ZFS storage so that critical metadata is passed to the storage with the information about the incoming database so that the storage can dynamically set up and tune itself on the fly to optimize the storage for precise incoming data. This represents a unique form of dynamic database to storage automation. This capability is only available on the ZFS storage appliance running the Oracle Database 12c. Oracle Intelligent Storage Protocol is tremendous co-engineering advantage for ease of use and simplification. First off, OISP enables the storage to respond directly to the incoming data, literally pre-tuning and pre-configuring itself to the database. I mentioned previously that our analytics can see containers and PDB level details, and OSIP is a mechanism by which that occurs. With that type of insight, the database, we can ID database-related storage issues with over 60% fewer steps than the competition. Oracle Storage is a position of knowing while everyone else is just guessing. That just makes sense since we know the entire red stack. So with OSIP, manual storage configuration tuning is reduced by about 65%, eliminating potential human error, and while accelerating performance. If one looks at the total storage administrator time spent tuning storage for optimal database performance, using OISP can reduce that from a total of 56 days down to 19 days. Look at it another way. OISP literally frees up administrators' resources by 3x to spend time on revenue-generating activities, or the same number of admins can get 3 times the work done. We can tune and optimize hundreds or thousands of databases automatically. Hybrid Columnar Compression, also known as HCC, is a feature that was developed in our Exadata product and for the Oracle 11g R2 database. HCC is also supported on the 12c database. This data warehouse example shows a 735 gigabyte database compressed down to 38 gigabytes. And you can run queries on the compressed database 8 times faster than on the non-compressed database. This is a free feature that is available in all our storage. This is not a licensable feature. It comes free included with the storage, and it works only with the Oracle database. So to speak of our management tools, let's talk about automation. I mentioned the performance and the benefits of HCC and the capacity. In addition to ease of use and capability, we've introduced with Database 12c is automatic data optimization, which when used in conjunction with hybrid columnar compression, provides customers with the ability to compress data and also tier it exactly when the data is best suited for it, based on heat maps that are tracking real-time usage patterns. So you could set the background policies based on real-time usage, time is saved, guesswork is eliminated. So the hot data would stay in your uncompressed, and then the cooler data would be compressed, and then the really cold data would be compressed, and you could archive it. So that's how automatic data optimization works. Now I'd like to talk to you about our enterprise flash storage. It's called the FS1 product. All flash Oracle FS1 storage enables you to maximize Oracle database storage efficiently and reduce cost. The all-flash FS1 is the only flash storage system that supports hybrid columnar compression. We can reduce static Oracle database data by 10x to 50x. The only all-flash system that maximizes Oracle 12c automatic data optimization value with H2C, and we can automate compression based on usage. We can reduce the dev test storage by 10x, or by using writable snapshots with virtually no storage consumption, created almost instantaneously. The FS1 can maximize the value of the Oracle database 12c pluggable database. All the FS1 flash storage performance needed when multiple databases are consolidated. Bottom line, with the all-flash FS1, you buy and manage 50 to 90% less storage than non-Oracle all-flash storage, savings that our competition can't beat. Here's just a quick overview of our storage product portfolio. As you can see, we have our SAN storage, which is our FS1 product, our NAS storage, which is our ZFS product. And we also have a zero data loss recovery appliance, which is a groundbreaking data protection solution that tightly integrates with the Oracle database. And we have our STK tape product line for deep archive. Thank you for listening to today's webcast. I appreciate the time.